large sample test where you are going to have the 4 different kinds of tests. Number 1, test for population mean, equality means of population. Number 3, test for population proportion, and test for equality of proportion of 2 different populations. From the point of examination of these 3, you are going to have one question from section C. So in that context, now we are going to discuss about test for population mean. The question would be asked like this: a sample of 100 students is chosen from a large group of students. The average height of these students is 162 centimeter and standard deviation is 8 centimeter. At 5% level of significance, can we reasonably assume that the average height of large group of students is 160 centimeter? Here our overall objective is, based on the statistic what we are having related to the sample, we are going to conclude about the entire model, that is nothing but populations. Now, so from this question, let us sort of the given things first. So what are things they are given in the question? A sample of 100 students. That means they are taken a sample of 100 students, nothing but n equal to 100. From a large group of students, the average height of these students is 162 centimeter. That means the height of those 100 sample students is 162 centimeter, nothing but the average height is nothing but average mean, that is 162 centimeter. And the standard deviation what they are given is sigma, that is 8 centimeter. At 5% level of significance they are given, that means alpha value is 5%. And the object of the question is, can we reasonably assume that the average height of the large group of students is 160 centimeter? That means they are asking us that the new value is 160 centimeter. Can we assume the new value as 160 centimeter? They are asking. So these are the information given in the question. So after listing out the informations what they are given in the questions, the first part of solving this question is setting or writing the hypothesis. Where first we have to set the hypothesis H0, where that always we have to assume it to be as equal to, that is nothing but H0 can be written as, we can reasonably assume that the average height of students is 160 centimeter. This is the H0. Where the alternative hypothesis we have to write opposite to that. Here what we are saying, we can assume the against alternative is that we cannot. So we have to write an alternate hypothesis like, we cannot reasonably assume that the average height of student is 160 centimeter. So you can write the hypothesis like this, or else you can also write the hypothesis. You can also write this hypothesis in terms of H0 mu equal to 160 centimeter versus H1 mu not equal to 160 centimeter. the first part of the questions we have to set the hypothesis that we have done. Then afterwards we should know the formula. The second part is we have to calculate the value that is given by z calculating equal to x bar minus mu divided by sigma by root n. Is the formula. Here x bar is nothing but sample mean, mu is nothing but population mean, sigma standard deviation, n is the sample what we have taken. Let us substitute the given value here. X bar here they are given it as 162 and we know the mu value 160 centimeter divided by sigma they are given it as 8 and the sample is 100. So after simplifications what we are going to get 162 minus 160 is 2, 8 divided by root 100 is 10, 8 divided by 10 we are going to get. Divided by 10 gives you 0.8, 2 divided by 0.8 gives you 2.5. I think that's Z calculated. Okay. After this, we need to decide whether this value would accept it or not. We have to check. To check that, we need to obtain the critical values for this. For that, we need to decide whether this test is one-time test or two-time test. Here, since we have taken it as not equal to, but obviously it is two-time test. Then afterwards, just draw the normal curve to get the reference. This is normal curve. At 5% level of significance for two-time test, at 5% level of significance for two-time test, the critical values are minus 1.96 and plus 1.96. So critical value is nothing but the rejection region. So this is the rejection region, RR, and this is acceptance region. This is also rejection region. So now just check where the calculative value lies in the normal curve. 2.5 is, it lies outside the acceptance region. It's nothing but 2.4 comes after 1.96 and somewhere here it comes. The Z calculated value 2.5. So that means here the acceptance region occurs. And these two hence the rejection region occurs where Z calculated value 2.5 lies out of the acceptance region. So from this what we can conclude, since the Z calculated value lies out of the acceptance region, since Z calculated value lies in rejection region, so what you can write the conclusion? Reject H naught. Since we are rejecting H naught, what is the conclusion? We cannot reasonably assume that the average height of the student is 160 centimeters. So it is very important to write the conclusions. So you have to follow all the steps what I have mentioned in the answer part. So that may give you the 5 marks. Clear? So in next class we will come up with the second method of the log sample test. Thank you.